haven't said anything crazy, and they keep bringing me back every year, so I hope to keep doing that. Just fair warning, the topic we're going to talk about is very complex. This is a lightning talk, so I have simplified the hell out of what I'm about to talk about. So all my fact checkers, don't sue me, okay? I'm trying to unpack a lot of things in a very quick manner. So why are we here? I don't know. Lately, I've been having a lot of existential crises and questions that I've been thinking about. Maybe it's where I'm in my career. Maybe it's the role that I have at a startup trying to build the program management function from the ground up. Maybe I'm just terrified of like what's coming to replace me. But I do end up thinking about this a lot. I used to write about this a lot, but I've just been busy with my second kid. So, you know, existential crisis, new dad, lots of things on my project list. So, you know, it drives you crazy. Fortunately, this is a lightning talk, so I will not be waxing and talking and spewing nonsense about my philosophical thoughts and whatnot, at least at this TPM conference. So we'll see if they bring me back next year, and maybe I'll do a longer one. But whenever I talk to TPMs in general, new, experienced, or people who are transitioning in from like different backgrounds, I get this question a lot. And it's usually followed by, which programming language should I go learn? Which certificate should I take? Which course should I enroll myself in? And I'm going to try to address this in a very roundabout way. One thing you'll notice about me, I do things very roundabout, so it makes things more entertaining. So I'm going to go on a little bit of a tangent before I come back and address this question. You have to understand, we technical program managers operate in a very complex world. And everything around us is constantly shifting, whether it's the paradigms, whether it's the systems that we're working on. And it's not just the jobs that we have. The industry and the technologies that we work with has been evolving constantly over time. And it feels like in the last 2 years or so, almost 2 centuries have passed of technological advancements. LLMs have gotten super scary fast. You know, devices are getting smaller, new form factors are coming out. There's a lot more that we can do, but that means that the things that we're helping build are getting more complex. They're more multifaceted. It involves a large cross-functional team with many, many different types of personalities and peoples and skill sets. And the scary part is now we've got a cross-functional partner that doesn't have a pulse, doesn't sleep, doesn't rest, doesn't need food, lies like a champ sometimes. And that starts to bring in an interesting question. What's the future of our role? Where it is very heavily, you know, there's a people aspect to it, then there's a technical aspect to it. And this is where I've sort of started to think about that perhaps the future is not what it was where we saw a move towards specialization, right? You had TPMs who specialized in cloud. You had TPMs who specialized in ML. You had TPMs who specialized in UI, in apps, in mobile devices, in mainframes. I think what we're moving towards is a world that is more generalist. You'll hear a lot of LinkedIn thought leaders talk about the full stack PM is coming back. Generalists are making a comeback. I would go one step further, and I would say that I think it is coming to a point where now all of us have to be specialists at generalization. We have to become good at everything and very fast. And the way I would describe it is like it's a systems thinker who's able to become an expert in any system, technology, and or paradigm in a short amount of time. And I want to focus on those 2 things right here, and that's the sort of the crux of my talk. But you're all probably wondering, what the heck are you talking about? We started with how do I become more technical, and you're talking about LLMs and AI, doom and gloom and being replaced and whatnot. I think the question is masked by the real question underneath it, which is not how do I become more technical. It's how do I learn a new technological stack or a system in a short amount of time. That's what everybody's asking, and they don't know that's the question that they have to go ask, right? they get stuck on the big T in front of our title, and they're like, I gotta go learn Python if I'm gonna work in data science. I gotta go learn this thing called Swift UI if I wanna stay in mobile. Oh my God, Replete AI, I don't know what to do. I need to get more technical. The good news is, this is what the point of the lightning talk is, and there is an approach that I have used over sort of my years working at Apple, Google, on different types of things, always in that 0 to 1 space, and it's called decomposition. And I promise you, there's a sort of a method to the madness as well, and I'll talk about this in a second. It's pretty simple, straightforward. You probably are already doing this in your day-to-day jobs, and you don't even know it. So what I'm going to try to do is I'm going to put a term to what you've all become really, really good at doing. And maybe give you a new lens to look at your expertise and your skill sets, and take that to the next level. So what is the method of, or the art of decomposition? It's a few things. Think about any technological system that you've ever come across, whether it's a website, whether it's an app, whether it's a chatbot, GPT, whatever the heck you guys are building, a new device, a new paradigm. Everything that is sufficiently complex is in itself a composition of individual simplistic systems that are stitched together by connectors that operate according to rules and constraints that have been placed upon them. That in itself is what complex systems are. It's very simple. Everything can be broken down to very finite things. This is called the first principles-based approach. I'm sure Elon Musk, all those followers wax about how great he is at first principles thinking, but if you went and asked them, what the hell is first principles thinking? They'll be like, it's first principles thinking. It's first principles, just do it, right? So this is something that I've been trying to do, is put a structure around that sort of concept. So let's dive into each one of these things, and I'm gonna try to see if I can finish this talk in under 25 minutes. Look, as I said, all complex systems are a composition of single individual systems. And every company or every place that you go, what you have to figure out is what is the atomic definition of a single system, right? Again, fact checkers, do not sue me. This is very simplified. The most common architectural pattern we're all aware of and that we learn coming out of university and college and just online is client and server, right? That is literally the entire internet and how it's designed and everything else on top of it. So you can break everything down into individual systems and think of it like those dolls within dolls within dolls. So you have client at the very top that can be further broken down into web and mobile, and each one of those can be further broken down into individual components and systems or frameworks, right? A mobile app can have a login page that operates as a UI framework. It has a product page, and they all operate in different ways. On the server side, you can have components and databases. The components are like accounts, payments, fulfillment. What we're talking about is a very simple e-commerce website or an e-commerce platform, right? So first step you do is you figure out what your overall system is, figure out what the atomic systems are, and just lay them out. Don't worry about hierarchy or anything like that. Does it fit here? Just lay it all out. And the next thing you want to get to is how are they all connected? Now I'm talking about SPIs, APIs, RESTs, tokens, the whole thing. You start to draw sort of these like a crime investigation, like you take a string and you attach it to this thing and say, haha, clearly this person killed that person and anything. That's not what happens, but you start to draw those strings together. And what you start to see is a map taking shape right in front of you. You get to understand where and how those systems are connected, how they need to interact with each other. Sometimes they will be bidirectional, sometimes they're just one way. Your goal is to figure out how all these systems are interacting. Then come the rules and constraints. So think about something as simple as a login UI. Everybody knows you never send passwords in clear text to the backend, right? But surprise, surprise, people still do it. And then certain pages you cannot view until you've logged into that system, right? And the reason why, and I think this is the most important part, and I'll tell you why. If you can understand how the rules and constraints are for a system, I promise you, you can go toe-to-toe with any engineer because you figured out how to make a system tickle. you know that if I move something from here to here, or if I deprecate this API, it's going to cause this system to fall apart, and it needs to be replaced by this. There's a sequence in which we deprecate a particular system and bring on a new system. All of these constraints and rules have to be followed. And most of the time, when you have bugs and things that you're dealing with, is when a system is not operating within its rules and constraints. The API contract you set, well, it's not working anymore. Yeah, because you're sending passwords in clear text, right? So, or you're not adhering to the security policies we've set around how long a token needs to be, alive before it's refreshed again. Or performance or latency is bad because we're like caching 15 times before we get to like the last endpoint, right? All of those rules and constraints. And what you will start to notice is that when you work on your next program or project, your tasks, the things that you want your engineers to build, are rules and constraints of how these systems will operate, right? So suddenly in the back of your mind, you're starting to see epics and tasks and subtasks and things like that, right? And you're starting to see milestones which you can establish, like, okay, the system is behaving this way. Great, milestone achieved. Let's move on with our lives, right? Now the last piece, this is something that if you take away anything from this talk, it's this. I want every single person in this room to be intensely curious. And when I say this is that you're always asking, why do we do this? Why do we do this? And this comes from my own experience at Apple. When I joined Apple, nothing was written down. Everything was tribal. And my first 3 months was just going around and having conversations with people and asking them questions. The really positive thing about being sort of intensely curious is that you start to learn how to ask better questions. And when you ask better questions, your programs are designed better. And when I say programs, I mean specifically your schedules, your milestones, your test plans, your performance criterias, your KPIs, your OKRs. Everything becomes better when you start to ask great questions. All the mentors that I've ever been thankful for, they've been great at asking questions because they're intensely curious. You become more prescient and adaptive because you're starting to develop a function in your mind where you're starting to see around the corner. When you ask questions, what happens if we do this? What happens if we do this? Shreya Doshi calls this like a pre-mortem. For anybody who knows Shreya, he's a fantastic voice in the product management community, great leader. And this lines up with like when we start to ask better questions, we can anticipate risk a lot better. Because we've started to ask, like, what if I do this? My wife hates it when I ask, what if I don't put the tomatoes in this recipe? What will happen, right? So the same thing you carry forward in your day-to-day. You will also grow as a leader because when you ask questions, you have answers. And when the next time you're at an executive review and somebody asks this question, you can be like, oh, well, this is how the system behaves. This is how we want to change it. And this is what will happen, right? So you start to see. But the best of all, the engineers will love you. They'll be like, oh, here's this person. Aadil asks a lot of great questions. Clearly, he knows what he wants to do. He has yet to ask me what the new ETA for that task is. Right? Like, what is the one thing that every engineer says? All you EPMs ever ask for, or TPMs ever ask for, is like, what's the new date, right? This counteracts that. It shows that you care, right? So, are there other approaches besides this that I have seen that can help you become more technical? And I'll be honest, a couple of months ago, I came across something that I have become obsessed about. And it's this C4 model by Simon Brown. He's a software architect. Check it out. It's really fantastic. One of the most difficult things for us to do on any technical program that we run is have a common lexicon in which to have a conversation with the engineers. This is perhaps the most simplest model that I've ever seen that brings that sort of technical mindset, but is simple enough for anybody without any sort of, or sufficient technical experience. Not like you don't need to know Python and, pandas and all that stuff. Like, it's all great if you know it. But it's a common language that you have to have discussions with your staff engineers, your senior engineers, your principal engineers, your software architect. Please do check it out. This is a talk on its own. He provides a great course on this. I think anybody who is a TPM should be an expert at systems architecture, but that's just me. That's it. That's a lightning talk.
Thanks, Aadil. That gives us time for questions.
Oh my God, bonus.
Yeah. Okay.
Always good to see you. Great talk. I'm curious to know, given your journey, and I've seen this from Apple, the way systems behave, the way you interact with engineers, to your journey of becoming the head at Human, what is that you have adapted in terms of software architecture, decomposition? Like, are you at a moral ground today where you could say, hey, this is my center of excellence in terms of how I would manage a program or decompose it?
Yeah, so I'm going to answer that by not answering your question. Look, I think the thing that I have observed over time is that as TPMs progress in experience, they get set in particular ways of doing things, right? They get set in, gotta do 2-week sprints. That's the only way to ship something. You gotta have a specific amount of uptime, they get set in a particular way. And what I've learned is that any great program or product that you build isn't always an act of conversation. You're having conversations with your engineers, but you need guidelines and rules to sort of have those conversations, so a common lexicon, right? And this systems of systems, the rules and constraints and things like that, it gives me that sort of standard template that I can apply to anything, whether that's an organizational process, whether that is a new systems architecture that we're trying to build, whether we're trying to take the entire billion iCloud users and enable, two-factor authentication by default. Not getting set in your ways and having templates that give you sort of a launch pad and then everything else on top of that is a conversation, that is something that I have had to work very hard on, because in every single place before Humane, I plugged into a pre-existing system, right? There's a way teams do work. Apple does it a different way. Google does it a different way. Nike does it a different way. And I always operated within a system that had pre-existed or predated me. Humane was the first time where I got a chance to really build everything up from scratch. And that's where I had that epiphany of shoot, we get really set in our ways, and that becomes in itself an obstacle for progress and for development, whether it's technical or organizational design.
I think we have just another minute, so not sure,
Great.
Unless it's a really quick question.
Clearly, you all understood what I was talking about, so there we go. Oh.
All right.
Okay. Oh, thumbs up. Okay, great. I win. Okay, great. This is great.
All right. Let's give a big round of applause for
Thank you.
Aadil. Thank you for that very insightful talk. Thank you.